Hey, good afternoon, everyone. My name is Kamil, and together with David, we are going to present to you a talk named "What RTE Flow Rules Can Your NIC Offload?" This is a result of a work that we did together with another student, Jakub Šuráň. I hope we'll be able to see his name on the screen as well. I don't know if I have to press anything. Okay, there we go. So to start off, I'll let David tell you something about RTE Flow and the challenges we're facing.
Okay, thanks Kamil for the introduction. And now let's talk about the RTE Flow. So I suppose many of you guys know what is RTE Flow, but let me introduce it. It's a DPDK API for offloading generic rules to NIC. So basically you can see in this example that there is a DPDK application which can offload RTE Flow rule to the hardware. So now the work that had to be done in the software can now be done in hardware. There's an example with a rule which counts and drops every packet with this given IPv4 destination address. Now if we look a bit more closely to the RTE Flow rule, we can see that it consists of three main parts. There is a list of actions, which defines the actions that are going to be applied to the packet. There are about 60 of those actions. Then there is a matching pattern, which consists also of up to 60 items that can be in the matching pattern. And then there are attributes, which can somehow affect the rule behavior in the hardware. I'm not going to explain them all because this presentation has to take only 20 minutes and it would take at least 2 hours. But basically that's what RTE Flow rules are made of. And from my point of view, RTE Flow is a great API, but it has its downsides as well. For example, I mean, it's kind of hard to explain. So I've prepared an example to explain what is bad about RTE Flow, or actually what is not that convenient for the user. So there is an imaginary example of a user, actually a company which develops a DPDK application, and they look for a hardware acceleration. So they buy a NIC, and their requirements are that it has to support RTE Flow. They want to offload at least 5,000 rules, and they want to also use masks in the matching pattern. So they found a NIC, they buy it. The documentation says that it supports up to 10,200 rules, and it supports masks, so they start to using it. They deploy it. First version doesn't use masks, because that's what they planned for the second version, and yeah, everything works fine so far. But when they try to add the masks to the matching pattern, for some reason only 200 rules can be offloaded, which is far too little, since their requirements are about 5,000 rules, which they want to offload, and it's not suitable for their needs. So now they have a hardware which they cannot really use for the new version of their application. So as you can see in this emoji, not everything works fine. And the question is why? Where is the problem? So, because the documentation says that it supports up to 10,200 rules, but for some reason they can offload only 200. So the answer is quite simple. The problem is in the hardware, because even though RTE Flow is a really generic API, the hardware is not that generic. And in this example, the card is made up of 2 engines, and one engine is used for the rules with masks in the matching pattern, and that engine has only capacity 200 rules. So that's why the problem, there were the problem. I mean, of course, you can say in this example, the PND developers of this NIC, they could just write it in the documentation. But we have to keep in mind that the RTE Flow is a really generic API, and as I said before, there are about 60 actions, 60 matching pattern items, and many attributes. So there are many rules that can be offloaded to the hardware, And of course, there are many cards, and the cards can run in different regimes. So it can sometimes cause problems. So even if the documentation says that the given NIC supports a rule, sometimes it's not true. Sometimes there are capacity issues, as here, and sometimes maybe the rules can be offloaded, but the throughput goes down to, let's say, 50% or something like that. So I think that's the problem we are dealing with. And now, how to deal with it? Well, since not everything can be read from the documentation, users have to check the RTE Flow support themselves. I mean, of course, there is a test PMD. Everyone knows it. It's, I would say, quite a good tool, but it's not the best for checking RTE Flow support, at least not for every case. Because it's just a command line tool, and if you would use it raw without any scripting or preparing commands, it would not be that suitable. For example, the developers in previous example would have to type at least 200 to 1 rules with the matching pattern, so they would know that there is this problem. So from my point of view, I think writing your own checking application can help quite a bit. But of course, then each of us would have our own checking application. So I think it would be best if we have one checking application and we could all use it. We actually wrote this application. So now let's hand over to Kamil, who will tell you more about this application, and maybe we all could use then use it. Yeah.
Okay, thank you, David, for the introduction to RTE Flow issues. So basically, we are developing an application called RTE Flow Checker, which is an automated application where you could run a single execution and it will generate hundreds of flow rules and will then provide an overview of the supported features of a given NIC. The application is also extensible by custom queries in case you need specific functionality that has not been covered by the automated generation. And we believe that the developer in the previous example would greatly appreciate it. Now, let me tell you something more about the application. Firstly, what do we check? Obviously, we check patterns, actions, and attributes, but we also check their combinations. So, for example, can we combine mark and jump? It's a very common use case, but can we combine them? Or count and drop? Again, very common use case. Or does the NIC support egress attributes? Or, as David said, partial masks, ranges in the matching patterns, or how many items with such items can we offload. Also, we try to measure some quantitative things like available flow groups or available number of priority levels. Also, one of the things we measure is maximum rule capacity, which is a use case similar to an existing tool called test flow perf. Now, when we do all the measurements and all the checking, we of course want to see some output, and as humans, we like to see it visually. So the output of our application is an RST text file, which can be converted into HTML using Sphinx. And in the example, we can see at the right side of the screen, we could see that it's only the top of the output, because the complete output has about 1,200 lines. It's very long. But we can see that the application checked attributes and also the first item of the pattern items, which is IPv4 in this case. And we could see that it checked support for full masks, which is exact match. It checked support for ranges, partial masks. It also checks how the rule can be constructed, which we could see in this slide. So, for example, in certain cases, you could specify a rule by only specifying a part of the matching pattern. So the first case is only specifying VLAN, and the PMD fills everything else. However, some NICs, you need to specify the full pattern with Ethernet, VLAN, and IPv4. And so that's another output our application can give you, which is a text file with all the tested rules in test PMD format, which are helpful for further manual analysis, and also visual comparison of the rule formats. Now, what is our experience with this tool and also RTE Flow in general? We are developing high-performance DPDK applications where we want to use hardware acceleration. And we, of course, use different NICs. And we also sometimes try to experiment with new NICs, and we would like to know what are the features. We want to have a full overview of the features before we actually decide whether we want to use the NIC in our application or not. Another use case we have is another team is designing a custom 400G DPDK-enabled NIC, and they have a priority to support RTE Flow, and they would also benefit from this tool being able to see what percentage of RTE Flow, or how much, how many rules, how many actions, how many patterns do they already support. Now, to conclude, we are looking for your feedback. That's the most important thing. Do you have similar use cases? Would you be interested in using a tool that generates an overview of RTE Flow support for a given NIC and a given PMD? If you see that you might have a similar use case, feel free to contact us at the provided emails, or if you can make it here in person. Thank you for your attention.
Okay, thank you for the quick presentation. In my opinion, that's a very valuable tool. We really need to, as you show, there are some discrepancy in RTE Flow support, and even more, we don't even know what are the capabilities today, really, or they are not tested. So for sure, we need that. Now the question is where we should put such tooling. My first idea was to have such tooling as part of DTS, which is going to be integrated in the main repository. No, what is your opinion? Did you already write something?
Right, I think we discussed it yesterday with Lincoln. Yeah, there is also similar work going on in the DTS team, I believe. And I think it would be a good thing to collaborate on that. However, I feel that this is not particularly about testing, more like it's a single application that generates an output for the developer. But I do agree that DTS would be a nice place, but I think it should also be available for the users to run themselves with their own setup.
Okay, so you mean the average user, I would say, should be able to run DTS very easily. So it's just a matter of packaging DTS properly, isn't it?
Yeah, if a user can use DTS easily, then it would be good. But from what I've learned, DTS is depending on a specific setup in the community lab right now.
No, it should not.
Okay, then.
But if there are some difficulties to run it, we can work on it. Okay, any other question?
Yeah, please. Thank you for your presentation. Quick question. How do you achieve the combinations, possible combinations? Because technically they are endless. It's 70 items or even more, and...
Yeah, of course, the tool currently is not checking like every possible combinations, because there is a lot of them. But there is a script that runs through the available actions and tries to and the pattern items and tries to just combine them together in a rule, and then tries to create or validate the rule. And so it's not every single combination. It's just the ones that we felt are the most useful ones. But in the future, I think it would be good to extend it even further.
Yeah, that's what I would like to add, because this actually was why we are here. One of the things that we don't know every use case of every user, but if we could collaborate to this, maybe another user can add another use cases, so we can check more stuff that we don't even know about.
I'll tell you what's my main concerns, and this is the major thing, is that RTE Flow is living. It's always getting added more things. So basically, I don't think a developer wants to push another, if he adds another item or another action or add support, so somehow it should be reflected automatically in the application. You don't want a developer, because then very quickly the application will be out of date. So that's the question that I think that need to be solved. How do you learn of new items, and how do you, items action, never mind. But that's something that I think needs to be considered.
Yes, I do believe that's a point of some further collaboration with the DPDK community.
Yeah.
Thank you.
Yeah, one question here. So, yeah. So I think not just cascading the actions. I think some NICs has limitations on how many patterns can be cascaded. So if you could check the number of patterns you can add, like Ethernet, IPv4, IPv6, like that, like how many patterns you can cascade. That also, it's matter of capability, just to add that.
Yes, I think that's also another valid use case. I think for now, this could be checked by the custom queries I mentioned, which is basically a way to specify your own set of rules that will be checked extra, apart from the automatically generated ones.
Okay, thank you.
Okay, I have another question. So I see this tool in a more general or a generic context, like it's what you do there is querying hardware features, and there's a lot more in DPDK. Like some are quite simple but interesting anyways, like what minimal MTU is supported by the NIC, or what maximum MTU, or does it support splitting MBUFs on RX side, something like that. And all that would be nice to have in a single tool and not spread around across a variety of tools. What do you think about that?
I think you have a good point. However, I believe that what we're focusing on is strictly RTE flow.
I mean, you're just focusing on that, but having these kinds of tools to really know what the NIC supports and generate reports out of it is quite valuable, in my opinion.
That should be DTS.
Yeah.
Well, so I know we spoke yesterday and stuff like that, and this is kind of benefit of the group. I think one of the things that we should probably do as a community is kind of look at the two toolings that are available, because one of my team members built up some of the RTE flow stuff that's now in DTS at UNH, where it does similar in terms of trying to programmatically check the rule. Can it be, validated by RTE flow? Can it be programmed? And then can it actually send the packet and actually enforce the rule that was programmed? So it's not just did it program, but did it actually work? But the gap that immediately jumps to me is your tool here is creating many rules all at once when it's looking at like the total sizes of those tables, it seems like. And some of the focus that was initially in DTS was more functional validation, since it was doing the packet generation piece to actually look at, can the rule do what it's supposed to be doing? So there's already some obvious kind of gaps and differences between the tool suites. I do agree that I think we want to avoid overextending the number of like sample apps or applications in DPDK proper, just because it becomes unmaintainable to keep up with as a community. Developers drift away and then it doesn't move away. Where, moving towards DTS and the idea of having that part of the main source code and part of the main application would enable the developers working on RTE flow to extend the test cases in parallel with the feature sets, and be able to have that kind of self-keep up and stuff like that. I do caution, trying to feed back what the sets are and then programmatically generate rules of like, kind of explore the state space that you might have for that becomes very quickly a very large problem set of the number of possible things that can be cascaded after one another, and how many layers deep can they be, and how many rules do you end up with. And then you just end up with a testing problem that might take more time than it is worth to solve. So there's some intelligence that we have to try to build into those toolings of what are those common use cases. Owen went through, I think, exactly that same step that you went through of like, what are the 10,000 most common rule sets that are used in there or whatnot, and can we program and check those, but not every possible permutation of every layer that could be there.
I don't think there's anything to add to that. It was a good point.
I think maybe the idea, I'm not familiar with DTS, but maybe the idea is that also the user may insert the use case that is interesting. For example, I'm interested in these kinds of RTE flow combinations, or I'm interested in what he says, this specific capability of the NIC. Or maybe, I don't know, I'm just thinking, but maybe.
Okay, any other question? Yeah, no?
Okay, that concludes. Thanks, guys. Appreciate your participating and facilitating discussion. Okay.